Hello, in this video we will solve this linear equation using elementary row operation. First thing we need to do is to write this system of equation as augmented matrix. Remember that augmented matrix is you take all the constant 1, 5, 8 and then the coefficient matrix 1, minus 2, 1, 0, 1, 2, 1, 1, 3 in here all together called augmented matrix. And then we need to do elementary row operation, which is this is very important to write it down. First thing you do, if you have 3 by 4 matrix, you must start with a 0 0, doesn't matter which one first, but you must have 2 zeros and 1 here. Then you move to the next step, which is once you have this 1 0 0, you need 1 and 0. Start with the 0 at the bottom and move to the 1. Once you have this, you move to the third one, which is the last term here must be 1. And this in here and this gray areas here, it could be any number. That leaves you with z equals some number, y plus some z equals some other number, and so on. And these terms in here, it's called the row echelon form. This is row echelon form. And once it's in row echelon form, you could use substitution and then solve the system, as we're going to see in this example. And this technique is called Gaussian elimination. Again, you may see the equation says solve the system using elementary row operation, Gaussian elimination, or you may see row echelon form. What does it mean is that you need z equal a number and y and some other number z equal number, and so on. You need to get into this matrix looking that way. So I wrote down the matrix to save some time. So here is the matrix, and if you remember I need a 0 here, so I need a 0 here. How do we get 0 in here? I will get a 0 in here by saying the row 1 minus row 3, move it to row 3. This is row 1, row 2 and 3. So if I take this number minus this number and the result, move it to this row right here. So we have 1 minus 1, it becomes 0, become here 0. Minus 2 minus 1, and the answer is minus 3, move it here. 1 minus 3, the answer is minus 2, become in row 3. 1 minus 8, the answer is minus 7. And now the next step we need, as we see here, I need a 0 in here, which I already have. Need 0 in here, I already have. So I move to this step here. Well, I need the bottom here equal to 0. That means here need 0. So if I need 0 here, I could use row 2 with row 3. And how I do that, I say 3 multiplied by row 2, that will give me 3 here, and add it to row 3, so become 3 minus 3, and move it, the result, to row 3. And so it's going to be 0 times 3 is still 0, add to 0 is 0, 3 minus 3 is 0, 6 because 3 times 2 is 6, 6 minus 2 is 4, and 3 times 5 is 15, minus 7 is 8. Now I'm moving, I already have 1 here, I need 1 here, but I already have it. And then I move to these steps here where I need 1 here. If I need 1 here, or what I need to do is take the row 3 and divide it by 4, and that's become my row 3, new row 3. So divide everything by 4, I have 0, 0, 1 and 2. Now here is the system of equation. I have z equal to y plus 2z equal 5, x minus 2z y plus z equal 1, and you use the substitution to solve the system. So if I move 2 in here, you will have y plus 4 equal 5, meaning y equal 1. And we have already have the x, so plug it in x, you'll have x equal 1. Plug it in y equal 1 and z equal 2, in here you have x equal 1. And therefore the system is 1, 1 and 2. This is the solution to this system using Gaussian elimination or row echelon form. I hope this was helpful.